Hello, Coach Travis here, and I've got another question that came up on the reflections that I wanted to address. It's a really interesting question. How do you know when a function is continuous and differentiable given only its graph? So continuous and differentiable, we know is an important thing because it comes up in the mean value theorem, that the mean value theorem only works when you are dealing with a function that is continuous and differentiable. So this is a great question. Before I start using the mean value theorem, I want to make sure that I have a function that's continuous and differentiable. And how do I know? If all I have is the graph, how do I know it's continuous and differentiable? And okay, so there's a completely honest answer to this question. And then there's a sort of morally honest question, or there's the 100% truth, and then there's the true 99.9% of the time. So the 100% honest truth is you don't. The 100% honest truth is that you can't, if all you have is the graph of the function, then it's not really possible to tell if it actually is continuous and differentiable. And what do I mean by that? Okay, well, let's think about continuous. So if I look at this graph, it looks pretty continuous. I mean, it looks like a nice continuous function, but how do I know that if I don't zoom it, how do I know that maybe if I zoom in 1,000,000 times, if I zoom in 1,000,000 times on that little circle, maybe I'll see a little gap, maybe there'll be a gap in the function. And, if all you have is the graph, there might be little infinitesimal holes that you don't see. So that's the 100% honest truth. But that usually doesn't happen. So I mean, the functions we deal with in this class on a habitual basis do not have infinitesimal gaps if you zoom in 1,000,000 times. That's just we don't deal with functions like that. So for us and in the real world, 99.9% of the time, you don't have to worry about that. So 99.9, so here's your 99.9% answer. To tell if a function is continuous, you just look at the graph and you see, do you see any gaps? Do you see any holes? Do you see any asymptotes? If you don't see any of those things, then it's continuous. So that's the 99% answer. Okay, and then what about differentiable? So differentiable means that we can have a tangent line. And so the thing you have to worry about with differentiable is you have to worry about there not being any pointy spots. So like if your graph has a cusp or something, those are places where the function is not differentiable. So all right, so your 100% honest answer is you can't tell if a function is differentiable just by looking at the graph. Because once again, it is theoretically, it's possible that if I zoomed in 1,000,000 times on that little piece right there, that it would look like that. It would have a whole bunch of jagged edges, and that would not be differentiable. Well, I guess I have to be a little bit careful there because I still have to pass the vertical line test. So maybe let me be a little bit more careful about that. It might look like, yeah, if I zoom in 1,000,000 times on that, it might look like, yeah, there we go. It might look kind of like that. It might have a lot of cusps, and that would be bad. Okay, but that, let's face it, that you'd have to have a pretty weird function to look this nice when you're zoomed out, but look this ugly when you zoom in. So 99% of the time, this doesn't happen. So 99% of the time, 99.9% of the time, this doesn't happen. In fact, never. I'm never going to give you a function that looks like that. So the 99.9% answer to this question is you look at the graph and does the graph look smooth? So if it looks, and if it doesn't have any cusps, if it doesn't have any pointy spots, if it looks smooth, then it's differentiable. So the answer to this question, how do you know if a function is continuous and differentiable? By looking at its graph. You look for, well, does it look continuous and does it look smooth? So if it looks continuous and it looks smooth, then 99.9% of the time, it will be it'll be continuous and differentiable. And so only if you're dealing with a really, really strange and highly bizarre function, which, let's be honest, I would never give you in this class, then you just have to look at the graph. And again, you just have to look at the graph, look for it being continuous, and look for it being smooth. And that's enough to be continuous and differentiable.